Hello everyone and welcome to the MathDBase.com Anicasts series. I'm your host, John Kisiedu. In this installment in the calculus series, I'm going to discuss the 1,000 most interesting integrals. Though algebra, geometry, calculus, and later number theory and group theory are usually studied as separate branches of mathematics, most students don't realize that these seemingly disparate fields are intimately interconnected. Periodically throughout this series, I will explore some of these interconnections. So let's continue with interesting integral number 999. First, let's rewrite the integral in exponential form, which will help us out later. So the cubed root of the quantity 2x plus 1 squared can be written 2x plus 1 to the 2/3 power. We are going to try to solve this by a basic u substitution. The quantity 2x plus 1 does not have an explicit derivative in the integrand, and the expression inside of the radical is also not the derivative of 2x plus 3, the other factor in the integrand. But we can still make a basic u substitution, then construct the integrand around that substitution. If we let u equal the quantity 2x plus 1, then du dx will be 2, and after separating differentials, du will be 2 times dx, and dx will be half times du. Now constructing the first factor based on the relationship between x and u in the substitution, the quantity 2x plus 1 is equal to u, so that quantity plus 2, or 2x plus 3, which is the first factor in the integrand, is equal to u plus 2. Now substituting all of this into the original integral, the quantity 2x plus 1 to the 2/3 will be replaced by u to the 2/3, the quantity 2x plus 3 will be replaced by u plus 2, and dx will be replaced by half times du. Taking the 1/2 factor outside of the integral and distributing the u to the 2/3 term we get, which we can integrate by the sum and power rules. So using the simple substitution u equal to the quantity 2x plus 1, we have converted the product of a polynomial and radical into the sum of two simple terms. Let's take a look at what would have happened if we had made the u substitution in terms of the first factor in the integrand instead of the quantity under the radical. If we had said, let the quantity 2x plus 3 equal u, the differential part of the integral would have been the same, dx equal to half times du. But we would have had to construct the quantity 2x plus 1. 2x plus 3 minus 2 equals 2x plus 1. So after that substitution, we would have a monomial multiplying a binomial with a fractional exponent. Very similar to interesting integral number 1000, and would then have to make a second substitution to finish the problem. So in problems like these, try to substitute with the multi-term expression under the radical or with the fractional exponent, so that afterwards you will have a much simpler integrand. Back to solving our integral, let's apply the sum and power rules to get, which simplifies to now converting back to x's using the original substitution, replacing u's by the quantity 2x plus 1. Then converting back to radical form we get, and the solution of our integral is